dive right in here. Well, yeah, hi there. Thanks for joining us here today. We're going to be talking about just kind of setting up some business continuity for VMware, and then dive a little bit into that complete disaster recovery. So this is aimed at home lab users. This is aimed at businesses, really kind of across the board there. So my name is Chris Alden. I'm a senior technical account manager with Synology America. Means you can ask me questions, and you can always reach out to the company and get a hold of me as well. So just going to dive straight in, really. We're going to be covering three main components. First, we want to talk about setting up high availability storage. We want to make sure that you have full local redundancy in place for not only your virtual machine hosting, but also all of your data in general. Next, we'll discuss setting up full local backup and file recovery in case of any data emergencies on site with our high availability cluster that we're going to set up. And lastly, we'll be covering the very important step of taking all of this backed up data and replicating it to locations off-site, whether it's another Synology device, another server entirely, or a cloud account. Preferably you do a few of those together. Just in case we were to lose our original site, again, due to some sort of disaster, that just makes sure that all of our pertinent information is easily recoverable so we can continue forward. So traditionally, I like to start these off with kind of a case study that we've done with some of our clients. Just for the sake of privacy, we sometimes redact the clients' names here, but I can let you know this is a communications service provider that we've worked with. So this company had over 120 virtual desktops and 90 virtual machines that they run for a growing client base. So these numbers are subject to grow as well. Now, as a company doing this, they had three main goals that they really needed to achieve here. First, they need to prevent downtime. The best way for them to do that, of course, is to set up local and remote redundancies. So in case any particular device goes down, there's something ready to take its place immediately. Second, they wanted to shift over to owning their own storage. So initially when they started the business, they actually rented storage space. But as the operation grew, they pretty quickly grew out of that business model. And they needed to get in place a more affordable solution that would also cover their redundancy needs. Lastly, they needed flexible performance and capacity. A lot of their virtual machines here were changing tasks and running a variety of different services, and their virtual desktops needed to increase performance to kind of maintain productivity. So they landed on Synology. Their virtual desktops were covered by a high-performance all-flash cluster that runs in high availability. So if either of these two devices goes down, the other will step in and maintain their operations. Their virtual machines, which is a growing component, landed on our most expandable devices. So as their storage needs grow, their device can easily grow with them, adding on additional bays to kind of keep their data capacities current and up to date as they step forward into the future. So if this is your first time hearing from Synology, hi there. I'll give you a quick rundown. Synology Hardware really covers a wide range of customer needs. We run the gamut from terabytes of storage to well over a petabyte of storage in a single deployment. The idea there being that whether you're a small kind of accounting firm or small business that needs 1 terabyte of storage for a file server between a few employees, or you're representing a large global enterprise that needs to store 500 terabytes of virtual machines and backup data, we want to have a variety of different storage and performance options kind of for everybody across the board. So that's our goal there, and we definitely hit it. We have over 35 NAS devices that we currently offer. All of this is powered by our operating system, which is called Disk Station Manager. You'll hear me refer to it as DSM for short. Now, this comes with every Synology device, no matter how big or small, and it's kind of the launchpad for designing your NAS to your exact specifications. There's well over 100 applications, both first and third party, available for direct download on these devices, with the idea being that you can tailor your NAS to fit your needs exactly, with no bloatware or nothing extraneous already pre-installed that you won't be needing. Now, one of our largest use cases is storage for virtualization, and this is something we really take a lot of pride in. We're certified as virtualization storage with really all of the major hypervisors: VMware, Citrix, Hyper-V, and OpenStack. We've also got all of the advanced iSCSI integration features that you would expect from such a platform, such as VAI, multipath input and output, and thin and thick provisioning. So really, we're focused here today on kind of this expandable storage for your VMs. Your VM host on your compute node where ESXi is sitting might not really have any usable internal storage. Some don't have any at all. So a lot of these devices might not even be expandable. So you really only have the storage that you were kind of given out of the gate on some of these compute nodes here. Now, by connecting your compute node to a Synology device via an iSCSI connection, you can expand your storage for your VM host to really any degree that you deem necessary. And that's all done through the storage console. You can directly manage and monitor your Synology storage straight from your hypervisor this way. Changing exactly how large any of the data stores you need is just kind of a few simple clicks on either end of the Synology device and of your vSphere. So what I'll quickly do here is just show you what that looks like. We'll set up just some easy iSCSI storage on vSphere here. So breaking in here, this is DSM. If, again, you're unfamiliar with Synology, this is pretty much what it's going to look like when you open up a Synology device. Whether it's a 2-bay or a 24-bay, this is what it looks like to start. So pretty average desktop kind of setup. If you're familiar with really any computer operating system, you should feel really at home here. What we're going to do is go to the top left-hand corner and click on the main menu. Then we're going to open up the iSCSI manager. Basically, this just opens up all of the applications that we have currently installed on our NAS. So the iSCSI manager here is what we're interested in. And the majority of our software starts with this overview tab. It just shows us everything that this particular application is doing here, and just kind of makes it really easy to overview all of this. So if we want to make a new iSCSI target here, just click on this, and then we click Create. So here we can name our target. It just immediately jumps into the wizard for creating this. Let's just say VMUG target. Yeah, good name here. And then for the IQN, I'm just going to go in and going to change this name as well. We'll just copy this because we'll need this soon. You can enable chat here if you kind of want that additional handshake or anything here, but otherwise we'll just keep that. Make sure again that this IQN is copied. Then I'll click next here. Now, right out the gate, you can also create a new iSCSI LUN as well if you don't already have one set up. So we'll go ahead and do that. You can name your LUN here, dictate exactly what volume it's going to be a part of, and then change the total capacity. So let's just increase this to around 15 gigs. And then if I pull down this advanced features tab, we can see that currently we're actually running thick provisioning. So it automatically has hardware assisted zeroing and locking enabled here. But if we want to do some of the features such as snapshots, things of that nature, we're going to want to change this over to thin provisioning. We can see those are automatically spaced in here. You can, of course, disable any of these as you see fit, but with thin provisioning, we just have kind of a few more options here, which will be particularly useful later for us. So I'll click next here, and it'll just have us confirm all of our settings. I'll click apply, and pretty quick process. It's going to create that target here. You can even go into the LUNs and see we now have LUN 2 here. We have quite a few on here, but perfect. So what we're going to do now, switch over to our ESXi. And forgive me as I enter the password here. So the next steps we want to do is we just want to get everything connected here. So make sure we're clicked on storage here. We're going to go to adapters. And here we're going to click right here and we're going to configure our iSCSI connection. So I'll click here and we're going to add a new static target right under here. And that is where we paste our IQN that we just set up. And we just want to make sure we're connected to the right web address here. So in this case, 1.1.123 for our testing environment. And this is looking good, but technically we could save the configuration here, but since we have kind of a lot of home lab users that might be interested, we're doing everything right now in a free ESXi environment. So we're going to have to manually change some of these advanced settings up here just to stabilize our environment, especially since we'll be doing some failovers later on. So here, I'm going to go to the advanced settings tab and I'll just scroll down a little bit and talk about what I've changed. So we want to change this login timeout here from the default 30 seconds to 60 seconds, as well as the no op here from 15 seconds to 30 seconds. And then the last piece, we're going to want to disable the delayed acknowledgements here at the bottom. I've already set all of that up beforehand, but if you're following along, you're going to want to do that here as well. And just in case you're going to be doing this later, we have a full guide available on our knowledge base that goes over, setting this up with a free ESXi environment, just so you can set this up kind of with ease. But this is just to prevent timeouts in case of failovers. That way we're not disconnecting any of this while we're performing the failover later on. So now I'll click Save Configuration here. And we'll do a quick rescan, refresh. And we'll go under our devices. And we should see our new 15 gigabyte capacity store here. So that's good. That's looking great there. And now what we'll want to do is create a new data store just based off of that. So here, let's say this is going to be VMUG data store, very creative title. Click Next. VMFS6 across the board. We'll make sure it's set up there. And we'll hit Next and we'll hit Finish. Click Yes. And now we should be able to go to our data stores here. We can see VMUG data store. Super simple process. Now it's on the Synology device. Everything's connected, and that's really kind of all it takes there. It's not too complex, which is nice. So we just got our data store set up with our Synology device, but let's talk about getting that first local level of full redundancy here by setting up a high availability cluster. So the short and sweet of it is that we've got our main NAS device that we've situated. We'll refer to that as Unit A, our active server. Now we have an exact copy of that unit, same model number, same drives, Unit B, our passive server, that we'll connect via a heartbeat connection. Now that connection makes sure that all of the data on Unit A is instantly copied over to Unit B. Thus, if anything were to happen to our active server, our passive server is lying in wait to take over, thereby becoming the new active server automatically, minimizing our downtime to be nearly non-existent, with the idea of we don't really want to lift a finger in case one of these things happens. This can happen at any time of night. We might not be awake. It would be nice if this process was automatic. So I'm going to show you that real quick. We'll go into the High Availability Manager and we'll open this up. So here we are back in DSM. And this time we're going to go to the main menu and we're going to open up the High Availability application here. So here we can see our cluster. We can see that it's between two bay units. And again, this kind of overview tab right out the gate will just show us everything that's going on here. We can directly manage this. We can update DSM for these devices or update specific applications. And we can perform a switch over just in case we need to right out the gate here. Scrolling down, we can just see all of the stats on our unit and any recent important events that might have been situated with these. On the host tab here on the left, we can kind of dive in a bit more granularly to each specific device. And again, since we're dealing with devices that look the same, if we didn't label these beforehand and we need to know which ones currently are active or are passive, you can just click this button here and the finding mode will actually make the unit beep and start blinking. So really easy way to kind of highlight that. Again, you can also perform any restarts or shutdowns of specific pieces of your cluster here as well. So under network, we can change the name of our cluster, and that's all well and good, but under service is really where we can do kind of a large majority of our work here. So for services, we can enable auto failover on any of these here. So again, we're using this as an iSCSI target. We definitely want to make sure that that's active, but you can do that for a variety of other services as well. And another thing I highly recommend is setting up a quorum server as well. So if you're unfamiliar, think about a quorum server as kind of a mediator that's monitoring the high availability cluster. What it really does is help prevent instances of a split brain error, which is where both servers become the active server at once, which is something we definitely want to avoid, as there's a bit of a process kind of in order to remediate the devices and get everything back on track. So it should be an always active server address, such as a DNS server that you have access to. It'll just help prevent issues by having the passive server actually ping the quorum server directly in the event of a potential failover being detected. So if it can't reach the DNS server, it knows that there must be a different problem, and it's going to deny it from switching to active, thus kind of automatically saving you and your IT team or you in the home lab kind of a massive headache down the line trying to get this all reset up and situated. So what we can actually do here is go ahead and kind of perform a quick failover. So I'm going to move this over here and kind of minimize this screen a little bit more. So we'll go over to our cluster here, and we have kind of a lot of virtual machines that are currently running on this, but this one in particular, our elementary OS. Let me see, I should have the password for this here. Yep. Okay, perfect. So this is our, our virtual computer. We have employees or something on this. It's working just fine, but what we want to do is, let's say that there is a failover. So let's go ahead and just have this switch over. It's going to ask if we really want to do this. We'll click yes. And the first thing we'll notice here is that DSM here on the left is actually going to freeze up as it kind of starts this switch over. On the right-hand side, we might notice as we're using our computer that currently it's still working. The VM is in good shape, but we'll probably notice pretty soon that this is going to start hanging. There's going to be a brief period where it's going to start queuing up our actions, and they're not really working instantly as we want. Now, on these devices, this failover is kind of under 1 minute is typically where we're clocking this, but some of our higher end devices, if you're working again for kind of a larger business and you really need a much faster failover time, some of our more high-end devices will fail over in much less time. So depending on your needs, again, we've more than likely got you covered there. So this is actually looking pretty good so far. We can scroll through the YouTube front page, see what's popular with the youth of America here. Oh, new Batman trailer, actually. I need to check that out. So this is still going. Just got probably a couple more seconds here. But when we do see that this starts to hang, which surprisingly it hasn't yet, this is doing actually fairly good, a lot better than my test runs. Once this starts to switch over here on the left-hand side, we'll see that now the sales HA1 will no longer be the active, the sales HA2 will be the active, and we got kind of a hang here for a second. This started to refresh. And there we go. Now it's changed that this side is now the active, and this actually did a pretty good job. This did not hang too bad. I think kind of switched over a tab there, but that's really about it. It's back up and operational, switched over the machine that it was hosted on. That's a pretty good one. That's pretty solid. So again, depending on kind of the tasks you have in place, some of these business class devices might work really well. And then of course, our higher end units, we have much faster failover times for kind of those more non-interruptive iSCSI services that you might be running there. So let's jump right back in here to the slide deck. Let me pull this up here. So for today, we're really running our demos here on a pair of 2-bay desktop Synology NAS units that your home lab or a small business might be operating with or interested in operating with. Our business class devices range from small to large, and anything Plus series or above is really going to be capable of all of the functionality that we're discussing here today. So now, as mentioned earlier, we do have some units that can perform faster failovers for more mission critical or intensive deployments. This here is our first active IP SAN designed for offices or users with more enterprise focused needs. Each controller has a 4-core Xeon processor providing great performance. The device as a whole can expand up to 36 drive bays. And it also comes with a 5-year hardware replacement warranty with next day air replacement in North America. And this is on top of the Synology lifetime technical support that you get with all of our products. Now, this design allows for faster failover times because that heartbeat connection that I mentioned earlier is built in internally over the PCI bus. So that just allows for a ton more bandwidth between the controllers. The syncing is thus faster, so are the failovers, allowing this device to be utilized for non-disruptive iSCSI services. So things such as 911 call centers, they can go ahead and utilize these products because we're guaranteeing that these will be non-disruptive iSCSI services. So let's take a quick look at 2 scenarios because we do have, again, all Synology business class devices being able to be deployed in pairs, kind of allowing for you to really configure high availability storage pretty simply. But there are a few things to consider when we're really looking at an HA build for ourselves. Now on the left, we have 2 units being used as an active passive cluster. And on the right, we have a single dual controller unit that is doing the same thing just in a singular chassis. Now, in order to expand the storage on the left-hand side, we would need to duplicate the amount of chassis that we're getting, as each controller would need their own. So if we needed 2 additional kind of storage chassis here, we're actually going with 4 since we have to do that for each controller. So depending on the units, the expansion we need, and of course the sizing of the drives we're purchasing, we could be looking at a pretty steep price tag, especially noting here that duplicating any hardware purchase or hard drive purchase is going to be a pretty tall order and is most often the kind of most expensive component, especially once we start reaching well into the double digits or even triple digits of a lot of these drive purchases. Now, however, by utilizing a dual controller unit, we don't need to double up on expansions, as those are actually shared by the head unit. That halves our drives cost directly, making for an overall less expensive solution that really solves the same problem here. So of course, on the left-hand side, there's merits for going that way. On the right-hand side, there's merits for going this way. But if you're following between these two and you're kind of looking at products of this caliber here, then might make more sense to go with the right-hand side there and save a bit of money. So let's take a look at another case study here. I always love jumping into these. Here we have a financial institution, and this is the dilemma that they had. They are operating around 175 virtual machines that are performing a variety of different tasks and services. Additionally, they have over 2,500 Microsoft 365 accounts for their workforce and 60 PC workstations on-prem that need to be protected. So there are a few hurdles here, of course. As a financial institution, they have several data retention regulations that they need to hit. And they really need to make sure that all of their operational and their client data is fully protected in case of any potential data disasters. Secondly, they need to make sure that in case a disaster does strike, they can very quickly recover everything exactly as it was and keep it operational. They really don't want to disrupt business, and they want to make sure that they aren't missing anything in case something gets shut down or broken. So they were able to really simply accomplish this with the use of a singular on-prem NAS device that is just acting as a unified backup for all of these different devices and services. They then were able to easily set up an offsite replication of all of this backup data that they could point to in case there's any disasters at their initial site. So let's focus in a little bit on this primary on-premises backup for a moment, and specifically how they were able to back up their virtual machines. Now, they were able to accomplish this utilizing the Active Backup Suite, which is one of our pieces of first-party software available on, again, any business-class Synology device. All of your PCs, your file servers, your virtual machines, and your software as a service platforms such as Microsoft 365 or Google Workspace can be backed up centrally utilizing this suite all into one device. Now, specifically for VM backup, Active Backup for Business has quite a few features. We have a completely agentless setup for vSphere VMs that makes backing up these devices really as simple as connecting to them. We also utilize full changed block tracking and global deduplication to minimize our hardware footprint when we're saving all of your data. So real quick, I'm going to jump in. Oh, actually, this isn't even the demo yet. This is the slide that my marketing team really loves to go over, which is that all of this is license free and available for free download on any Synology business class device. And now I'll go in and actually show you how this works. So here we are back in DSM. This time we're going to go to the main menu and we'll open up Active Backup for Business here. So when you open this up, you're greeted with that overview tab immediately. And I'll just run you through this real quick here. On the top left corner, we can see our protected devices. So everything that we're currently connected to and that we're currently backing up in one form or another. On the right here, we have the backup calendar, which is a really easy way to see if there's anything that is going wrong. So here we can see this is green. This is a successful backup. All of these tasks were completed perfectly. Red, something didn't occur here. There was a failure for some reason. We can see that we then had fixed it after the fact. And yellow here denotes that things were successful, but it threw up a warning. And if we actually click on this, we can then open up all of the logs pertaining to these backup tasks. We can see there's a partially complete here. And if I open that up, it'll actually give us the exact reason. We can see that a specific unit here or a specific VM here was unable to back up, or it was partially completed. And it gives us a reason there as well. So that's a real easy way just to check if anything is broken. That way you can go in and fix it. And if you are getting any sort of errors or anything of that nature, you don't have to necessarily log into DSM and check every day. You can get notifications for that sent to you in a variety of different ways, whether it's an SMS or an email or push notifications. Ongoing activities will show if a backup is happening currently. Last backup time, pretty self-explanatory. And then the storage status here is always a lot of fun to point out. So we can see that the virtual machines, PCs, and physical servers, these are actually all being deduplicated against each other. So if there's shared data, such as virtual machines running the same operating system as your PCs, that will actually all be deduplicated using shadow copy services. So we'll keep a copy of that data exactly once and then just reference it for all the other backups. You can get some pretty big deduplication rates there, which is fantastic. Logs, of course, we already took a quick look at that. And then transmission trends is particularly useful when you have a lot of different backup tasks. Just shows you which tasks and which devices are kind of taking up the most of your bandwidth here. Now, to actually make a task, let's go ahead and click on Virtual Machine here on the left-hand side. And here we can see all of the vSphere setups that we have currently. So if we wanted to make a backup for any of these particular devices, all we have to do is click Create Task. Now, when we do that, we name the task first, so VMUG task here. And then we can actually open up here and kind of pull up our data center. So let's say we're going to take that elementary OS that we just spun up. We're going to take that, back it up, and we're going to back it up to the Active Backup for Business folder here. So I'll click Next. It'll ask if you want to set up any sort of compression or encryption there at the destination. We'll click Next here. And now we have kind of a few task setting options that we can jump into. So you can set up your maximum concurrent backup to go to up to 30 devices, which if you have a bigger unit and you have a lot of VMs you're backing up, You can set it up to go pretty high, but you might be saturating your network there. You can enable change block tracking right out the gate, as well as application-aware backup, which is particularly useful for some of these applications on these VMs. Enable compression, encryption, and you can also enable a data store usage detection, which will mean that if our free space in this data store is less than any percentage that we dictate, it won't accomplish that backup, which can be pretty useful. Another great feature here is the backup verification. So if you have some really important VMs that you really don't want to lose, you can enable backup verification, and after the backup is complete, the Synology device will actually spin up the VM for you and take a video of it booting up and going through kind of the full process for any time that you see fit. Defaults to about 2 minutes there. But it'll take 2 minutes of video just to show you that the VM, its integrity is fine. It's booting up from the backup, so you know that your backup is all set. There are advanced settings you can set in place. If you have certain scripts that you want to run, you can go ahead and set those up there. We'll click next. And then here, it's just saying the VM that we do want to back up, the one I'd selected. Just getting that all situated. We'll click next, and now we can set up our schedules as well. So you can, of course, do a manual backup, but I don't actually know really many people who do that. Typically, we want to be setting up scheduled backups just to make sure that this is running automatically. This is set it and forget it. We don't have to worry about it. And if something does happen, again, we'll get notified and we'll make sure we can fix it. So you can run this on particular days of the week, change exactly how often you're going to be running this and what times exactly this could be starting. You can also configure backup windows here. So if you don't want it to back up while people are in the office, for instance, you can set that up here and just kind of block out a series of time where this will not do a backup and it is allowed to back up in these off hours. That, of course, works by the day, or you can get really granular and say, 5 in the morning on Mondays, I don't want it to back up there. Click OK, and now that's just part of the task. Click next. And now you have your retention policy. You can either keep all the versions or you can apply the following methods and design this exactly how you want, keeping just a certain amount of versions over the years or over the months, however you need it to be. Click next there. And now you're just saying who gets to restore this. So we have a lot of different users here, but let's just say really we just want the admin to be able to restore this, or the admin's team. Anything of that nature, you can set that up here pretty easily, either by local users, local groups, or domain users and domain groups. So we'll click next there. Just has you overview everything here. You click apply. And now that's going to back up at the time that we set up. So we can see VMUG backup task here. It's not backed up yet, but it will be backing up at 3 a.m., which is, I guess, when I set that there. So I can look forward to that accomplishing basically when I need it to. So now that we've backed up the virtual machine, let's talk a bit about the recovery of these virtual machines and other devices that we can back up, since we have quite a few options. You can easily accomplish full system restores on any Windows PC, Windows Server, and VMware or Hyper-V VM. This also allows for a file-level restore of these platforms as well as file servers. Now, for VMs specifically, you can accomplish an instant restore to the VM host, enabling cross-platform recovery, or even go as far as to spin up your VMs directly on Synology's Virtual Machine Manager, which, again, that comes in useful if your VM host encounters a major disaster, but you do need immediate access to your VMs. That way you can just spin it up on the Synology device that's already storing its backups. Another cool functionality here that I don't see talked about too much is that you can promote a full Windows PC backup to a Windows Server backup, as that's really just a different denotation within our system. This means that you can spin up any of your full Windows PC backups as a virtual machine on a VM host or on the Synology Virtual Machine Manager, allowing you access to a workstation and its data just in case the original PC is rendered inoperable for any reason there. Let's focus a bit more kind of on this instant restore functionality real quick. So a traditional full restore, of course, means that if you have an issue on your VM host, you'll need to restore the full backup image of the VM back to the host. Now, depending on the size of this VM or how many VMs you lost, this could take quite a bit of time. It is, of course, best practice, so definitely recommend you eventually do a full restore, but if you're in production and you need this data right away, it might not be super feasible to wait several hours to regain access to your VM. Now, with instant restore, however, you can wait on doing that full restore until you have downtime or after you've accessed and pulled down your mission critical data. Instant restore allows you to mount that backup image directly via NFS on the Synology NAS, automatically becoming an NFS data store for your VMware environment, allowing you to get back to work very quickly. Now, the recovery time of this process is equal to the time it takes to boot up the VM, essentially. And it allows you to push that full restore down the line to when you're able to functionally accomplish that within your time or your production restraints. So jumping back real quick to our friends at the financial institution, there's really one more piece of this deployment that I would really like to touch on here. And that is, of course, this last piece here, the offsite replication of their pertinent backup data. So there's another piece of license-free software here that we offer called snapshot replication. And that's exactly how we can replicate our data simply to an offsite location. Now you can take snapshots of any of your data stored on the Synology NAS at any schedule that you see fit, as frequently as every 5 minutes. You can then take that data, send it over to another Synology NAS on a similar schedule to make sure that you have local and offsite protection of any of your important data. Real quick, we'll just open up snapshot replication here, main menu, and we'll navigate here. Now here again, we have the overview tab. We can see exactly what's scheduled and what isn't scheduled protection. We can see all of our various snapshots that we've taken and completed replications as well. Now to snapshot data, it's super simple. You can click on this, you can click snapshot, take a snapshot directly there just so you have at least one copy. Or if you go to settings, you can set up a schedule just as you need to. Frequency can be pretty granular here. If we go to more options, we can even, again, set this to as frequently as every 5 minutes. But let's say once a day is looking good for us. You can set up our retention here as well, and you can dive in pretty deep on the retention policies just as you can with active backup. Or you can even just specify the amount of recent snapshots that we want to retain. So in this case, I'm going to say the last 1,024 snapshots. Let's go ahead and keep that there. I'll click OK. And it'll just immediately set that schedule into effect there. So now we've got this active backup for business folder where our VMs are backed up to, protected locally with read-only snapshots being taken here. Now, if we want to send this to another device, we just click on replication and we click on the folder that we are currently snapshotting. And if we're trying to kind of back this up to another device here, we just click create, click next. We can dictate if this is going into another volume on the same server or to a remote location. Click next, and then you simply enter the login credentials and the server address here. But since I've already done that, I'll just go here and click on this info tab. So here we can see that I'm currently actually backing up this data from my source server to a destination server here. You can see exactly when this was happening, when the next run is going to happen. If I go to statistics, we can see exactly what these successful run rates look like and the average amount of time that this is taking. And then here, if we have a particularly complex setup here, we can click on topology. So here, it's really just unit A snapshotting over to unit B. But sometimes you have 10 branch offices that are all snapshotting to a headquarters office. That way you would be able to see exactly which units are snapshotting where. You would see all of them pointing to kind of the mothership there. And you can, of course, have these snapshotting to each other or to a variety of different devices. Topology will just help you see exactly what units have where your data is going, which is more useful for kind of larger organizations that have a lot of these, doing a lot of these tasks there. For recovery, just click on the recovery tab. You can pull up really any of these snapshots for this active backup for business folder. We can go back in time, see exactly when these snapshots were taken. Then we can either just open it up and pull specific files, or we can restore that folder exactly as it was to the snapshot, or even clone it with a new name in case we don't want to overwrite any of our data there. We see this a lot in the cases of ransomware, where people will just go back to a snapshot and restore that folder exactly as it was. So that's how snapshot replication works. Now, back to our case study, friends, here. We, of course, have one other layer of offsite protection that we really should be considering here, and that is, of course, backing up all of our data to the cloud as well. Now, Hyper Backup is another piece of software that we offer, and that can take any and all of your NAS data and send it up to any of the major cloud providers that you might already have an established relationship with, such as Azure, Dropbox, Google Drive, or really any S3 compatible storage service as well. I know we have a lot of different S3 options, such as Wasabi, that I see a lot. If it's S3 compatible, consider it compatible with this. Now, we also offer our own cloud service as well, which is called Synology C2. And what's great about this is it's fully integrated into the DSM experience, and perhaps even better is it has no extra restoration costs associated with the service. This can be particularly worth looking into because some cloud services will implement extra fees if you're pulling down large amounts of data, which you would be in case of emergencies. So that potentially leaves you with a large bill to foot on top of your kind of already problematic situation. C2 also fully encrypts your data before uploading, making sure that it's safe on-prem, in transit, and in the cloud. So for my last little piece here that I'll show you, let's just go ahead and make sure that all of this VM backup data that we've set up over the course of the day is now also safe in the cloud. So you can probably say it with me now. We're going to click on the main menu. This time we'll click Hyper Backup. So here we can see we have kind of a few tasks here, but really simple. If we want to make a new task, we just click on this large plus sign, and then we can either do a data backup task or a LUN backup task. So in this case, I'm taking all of that active backup data that's holding my VMs that we backed up, and I want to send that up to the cloud. So when you do that, again, it's a very wizard-based operation, very simple to navigate. We can back this up to another Synology device or to a USB that we plug into our Synology device, to C2, to different file server protocols. So if you have other servers here kicking around in your office or in your home lab, you can back up your Synology NAS data there as well. And to, again, a variety of different cloud services. So we'll just make a C2 backup task here since I have the login credentials for that. Now it's going to ask me to log in to my C2 account, which since I just did this morning, it should remember me here. And then I'll show me my C2 data store here. And we'll see exactly how much data I have left in C2, which a pretty good amount. I've barely used any here. If I did need to upgrade, I could just click that here. And if I wanted to change which data center I'm utilizing, I can go ahead and do that. We have 2 currently, but we're always looking to expand to more. So here I'll click next. And I'm just granting access for Hyper Backup to kind of log into my C2 storage on my behalf here, so I can create this backup task. So here, we'll create the backup task. It just creates a directory in C2 that is the name of my unit and the date and time that we're accessing this. Click next, and you can do full volumes or, again, just kind of specific folders if you need to here. We'll take, let's just say, kind of any of this data here. Yeah, we'll just grab the critical backup files. That sounds like a pretty good one here. And you can also create file filters here as well. So you can include specific files, or if there's certain temporary files that might be kicking around some of these folders and you want to make sure you're not necessarily sending that up to the cloud, such as .mp3, just click that. And now anything that's a .mp3 in that folder will not go up to the cloud. Just a good way to make sure you're not storing lots of strange temporary files that you might not really want in kind of a more archival cloud storage. We'll click next. And I always recommend people take a look at this at least. So I typically always back this up to the cloud for myself. This is just all of the settings that I have for my various applications on my NAS device. So if I did lose my NAS device, if I knocked it over, if I spill soda on it, if it explodes for no reason, this way, when I replace it, I can then kind of get all my settings back. I don't have to go through all of these all of these steps again and making sure everything's back in place. This way it's kind of safe and secure just in case I do lose that device. Click next. We can name our task here, which let's go ahead, VMUG C2. And again, you have kind of a lot of options here. You can set up bandwidth limitations. If you have large amounts of data going to the cloud, you can make sure that they aren't always taking up kind of all of your internet speeds here. Enable backup schedules, integrity checks of the data in the cloud, and of course, client-side encryption as well, prompting you to enter that password information when you perform these backups. Click next. You can enable backup rotation. And again, you can do this to any kind of customized retention policies that you need, just to make sure that you're storing the appropriate amount of data up in the cloud. And we'll go ahead and enable that and then click apply. Now, what it's going to do from here is it's going to start communicating with the cloud from my Synology device. And it'll ask me if I want to perform a backup now, or if I have it on schedule. I can just opt out and say no, and it'll just say that no backup has been done yet, but this will back up at this next time here. So now we've gone ahead and taken all of our data. We've backed it up from our VMs to our Synology NAS. We've then snapshotted that data over to another Synology device. And here we've also sent it up to the cloud. So in under an hour, we've set up a pretty comprehensive backup plan that covers kind of all of our bases, which is exactly what we want to be doing there. It's really easy, and it's something that maybe if you aren't doing it at the home lab, you definitely should be doing it for your businesses. So highly recommended practices there. Well, folks, that just about does it for me here today. We're super keen to get your opinions on Synology and, of course, on any of our presentations. So here we're offering the chance to win a DS220 Plus, which is one of our 2-bay desktop NAS devices that's really capable of all of the things that you've seen demonstrated here today. So please take our survey here, and you'll be automatically entered to win at the completion of the survey. If there's any questions, myself and my colleagues are around. You're here for the next couple of minutes, or if your question isn't directly answered and you have something that comes up later, you can always reach us via email, and we're always happy to get back to you afterwards.